Hi class, in this video we're going to continue to talk about circle geometry properties, and the property we're going to talk about in this video is tangent radius property. So this property states that if I have a tangent line, so a tangent line is a straight line that touches the edge of a circle at only exactly one point, and that point where it touches is called the point of tangency. And it states that at that point of tangency, the radius will be perpendicular to that tangent line. And if the radius is perpendicular to that tangent line, it means you're going to get a 90-degree angle on this side and also the other side of that tangent line where it pretty much meets the radius. And now let's go over some examples using this property. Okay, in this example, I have a diagram. And in this diagram, I have AB, which is tangent to the circle at point D, and BE, which is my line here. It contains the diameter FE, and I also have angle ABE be given as 50 degrees. So I'm going to use that to help me answer my questions. My first question for A is, what is the measure of angle BDC? So angle BDC is here. So that means they're looking for the angle of D. And according to my tangent radius property, because I have a tangent here that's touching exactly one point on this edge of the circle, D is my point of tangency, so hence this must be 90 degrees here and also on the other side. So for A, my answer is just going to be 90 degrees. Now for question B, what is the measure of the central angle DCE? We're basically asked to look for this angle here, okay? I'm just going to call this angle X, okay? I'm going to look for that X soon. Um, Recall central angle is formed by two radiuses, okay? And now there's a few ways to solve this question. I'm just going to use the method that I feel would be the most simple. So in this method, you have to recall one thing. The angles in a triangle all add up to 180 degrees. So right now, I know two angles in my triangle, and I just don't know this angle here. So I'm going to call this angle Y. I'm going to want to look for that angle Y to help me find angle X. So for angle Y, basically, if I had Y, angle Y, and I added it to 50 degrees, and then I added it to 90 degrees, it should equal to 180 degrees because angles in a triangle have to add up to 180 degrees. So since I knew this, if I wanted to find Y, all I have to do is take 180, subtract it from 90, then subtract it from 50. And that would get me my degrees for Y. So in this case, 180 minus 90 minus 50 would be 40 degrees. So Y would be 40 degrees. Okay, great. Now, how does knowing Y help me solve for X? Well, recall, angles in a straight line must add up to 180 degrees. So if Y is 40 degrees, I can use that knowledge to help me find X because this all has to add up to 180. So what that means is X plus 40 degrees equals to 180 degrees. And because I know that, if I take 180 and I subtracted it from 40, I would get 140 degrees. So in this case here, X must be equal to 140 degrees. And X would be my angle DCE. Okay, now for C, it asks us what type of triangle is CDE. So to help me answer this one, let me just use a different color and I'll show you what I mean. Notice from C to D, that's the radius because I'm going from the center of the circle to the edge. And looking at line C to E, that is also the radius because I'm going from the center of the circle to the edge. Since now I have two radiuses, which are both the same length, I have two lengths that are the same on a triangle. And since both of these lengths are the same, it means I have an isosceles triangle, right? So in an isosceles triangle, one thing we need to know is that the opposite angles are equal from the sides that are the same length. So what that means is angle D must equal to angle E. Okay, we can use that later to help us solve question D. But for now, let's just answer the question for C. What type of triangle is CDE? It's going to be called a isosceles triangle. Okay, great. Now, D is, what is the measure of angle DEC? So they're looking for angle E here. Okay. Explain your reasoning. So right now, we know that angles in a triangle still have to add up to 180 degrees. And I have these two angles here. But these two angles are the same, right? So far we know that angle D equals to angle E. So let's just call them something. Let's just let this be another letter here. Let's let it be Z. And I have both of these equal, so this is like 2Z pretty much, right? So I'm going to have 180 degrees, and if I add 140 degrees, which I have here, to Z, which is my angle E, and I add it again to Z, which is my angle D, I could use this algebraic equation to help me solve the problem. So right now I'm going to have 180 equal to 140 plus 2Z. Okay, great. So that means if I subtract 140 from both sides, I'm going to have 40 degrees equals to 2Z. And if I divide both sides by 2, I'm going to get 20 equals to Z. So that means that this angle here for angle E is going to be equal to 20 degrees.